Hello everyone, welcome to Can.Do.So. Today I will continue to show you how to visualize data with ggplot2. This is the second part of this course. So let's get started. Last course I showed the basic functions to data to visualize the data with ggplot2. We use a example of a scatter plot. Use two numerical variables. However, there are several different situations. For example, how to visualize a categorical variable, how to visualize one categorical variable and one numerical variable, how to visualize two categorical variables and two numerical variables, and even more, three or four variables in the same data sets. This course I will show you in which cases we use this one, in which cases we use that one. So first let's load the libraries which we will use. The tidyverse. Tidyverse is because it includes the ggplot2 and other variables we are using: dplyr, idea, radar, forecast, ggplot2, and so on. And the Palmer penguins we have also used last time. It's a data penguins data set we are going to use. So before you start, I recommend you follow this new file and quota document. New quota document and use the title like this, like mine, like this data set, and choose HTML and create. So you can delete all this. So you will make your practice well organized your file and you can review it. So I have already created, so we don't need. So let's go to the first one. Yeah, first we actually use the visualizing distributions. Distributions, which means how the variables distribute. So in which number there are more observations. In each range there are a few observations that comes in. So first I'll show you a categorical variable. We use a bar plot to show a categorical variables distributions. Categorical variables, which means is a type of variable used in represents types of groups. Unlike numeric variables that have a quantitative value, categorical variables represent qualitative data, are typically divided into distinct groups or categories or types. So categorical variable we cannot tell how big or how less. We just can count how many in each group. So there are two main types of categorical variables. One is nominal variables. Nominal variables, which means we cannot tell the one group or one category is better or worse, or high or low, or that kind of things. A good or bad, for example, the male and female, red, blue, green, apple, orange, banana. Maybe in someone's favorite, someone would be favor red color and instead of green or blue, and someone will prefer orange against of apple. But normally we cannot tell which one is good or bad or that kind of thing. So that is nominal variable, and the other is ordinal variable. In ordinal variable, we can tell we can rank it from low to high or high to low or good to bad or bad to is strong or to weak. That kind of thing. Something like stronger agree, strongly agree, neutral, disagree, strongly disagree. So in political science, this is a very typical rank. For example, we want to survey how people like the policies or like some candidates. Or education levels, in this case, we can rank it from low to high, from high school to PhD, such kind of things. So how do we visualize the categorical variable? We use bar plot, G on bar, because in last course we use GOM point that is scatter point. But here we use GOM bar. Okay, this one. So there are three species. One is Adeline, chinstrap, and Jintu. There are three species of penguins. And in X variable, we use species, and Y variables we count how many in each group, in each category. So Adelaide, there are about 150 count, and in chinstrap we have about 50, about 60, and Twin is about 125. Yeah. We can test that use our table function. It's yes, yeah, that's it fits our so this one is 152 and 68 and 124, right? Okay, I'll show you a little uh, scale of the high coding. Here we use mapping equals to, because every plot is visualized by ggplot, we use mapping. So we can omit it. We just use AES. We delete this. We delete this. So that does not change the outcome. It's the same. Now, this looks not from low to high or high to low, so it looks a little ugly. So we make it better, a little prettier. We use this. Yes, this in this way we just add this function, this which means a factor in frequencies orders from high to low. So frequencies, so 150 is the biggest frequency, most frequency, and the middle frequency, and fewest frequency. What if we want to go from low to high? Yes, we also have solutions. So this one is factor reverse the ranking order, so it becomes low to high. And yeah, that's one categorical variable. Now we'll go to the one numerical or quantitative variable. So quantitative variable is can take on a wide range of numerical values. So here we use histogram to visualize the numerical variable. Histogram. Okay, this is a little unclear. So we can change the argument. In one way, we can change how wide each bar is. So we use a bind width argument used here. This is 20. So it's 20, we make it smaller, narrower of each bar, each band, each bin. And how about 20? Okay, each bar is bigger. Okay, and how about 2000? That's even bigger. So there's only three. Only three. This is 2000, 2000 much bigger. So it's only three being snipped. And we can also use the bins, which will set the number of bins. What does this mean? This means we use 1, 2, 3, 4, and so on, all the way to the 20. So there are 20 bins, 20 bins. But we can also use, for example, change to twin bin, 10 bins. So there are only 10 bins. You see, 1, 2, 3, 4. So both ways we can change the scales of the plot. Okay, except the histogram, we can also use density to visualize the data, visualize the quantitative data. Quantitative data. Okay, this is a quantitative data. Actually, this is the this one. So it looks like the histogram. So this actually histogram and density is the same. It shows in different way. So we can add it together. So histogram and the density. One way is we add a histogram ASY equals to dot dot density dot dot and plus the density argument. So in this way, yeah, we got the. So there's another way to show the density. There are two ways. So here we add a y stat density here, not here. You see the difference, but the outcome is the same. Yeah. So that's just now we just showed one single variables, and now I'll show you how to visualize the relationships. The one thing is the first one is a numeric and a categorical variable. So species is a categorical variable, body mass is a numerical variable. So we use box plot to show it. Box plot show one categorical and one variable, one numerical variable. So this is Adela's box plot, the chain strips box plot, and Can.Do.So box plot. Here shows their, so you can see that the Can.Do.So median is much higher than the Adela and chain strips median. And here is a outlier, and here's an outlier. So the chain strips deviation is more wider than the other two, you can see. Okay, we can also use the density to show a species and show a categorical variable and numerical variable. Okay, we use outline red color to show outline, green color to show chain strip, and blue colors to show Can.Do.So. And we can also change the lines. For example, we make it bigger. Yeah, the line is much thicker, and so change to 1.5. It's thinner. So you can choose your. Notice that in densities, this is a share. This is share. How much percent of these numbers, for example. But in histogram, this is number count. So how much is this 80? So this range values is there are 80. So you know that, so this is a percentage point, proportion, and this is count. So you'll notice the difference. And also we can use density with fill. Notice the difference between this one and this one. Yeah, we have a fill, so looks a little right here. The alpha is shows a transparency. Yeah. So if we use a 1, so there's no transparency. So you can't see the one in the back. But we can, if we make it smaller, then transparency will be more transparency. So we can see the back. See through the green one to see the red one in the back. So that's the alpha argument means. And here we add a fill species, fill X species. So how about we delete this one? For example, I don't even know what it will look like. Oh yeah. This looks a little weird because the marginal line is black, so there's no color. Okay, how about 2 category variables? So this is Ireland and this is species, both are category variables. So we actually use bar plot. We use bar plot to show 2 category variables. So in this way is here's the position stack is one on the shoulder of the other one. So this one is the red one outline stand on the blue one, outline stand on the green one. This one are all outline. So this is default. Stack is default, so we can default which means we can omit it, then and we will get the same outcome. Then there's a dodge. Dodge is will give you the bar plot side by side. So here the outline does not stand on the shoulder of the blue one, but stand side by side. This is stand side by side because this one are all outline, so they are just the same color. So this is dodge means. How about a fill? Fill, you see first, they are all same height. Here, each group is not the same height. Here is not the same height, but here is the same height because this one stands for percentage. This about 75%, and this 25%. This is about 45%, and this is 55%, and this is 100%. So there's all the 100%, so they are all the same height. So fill means it's shows the percentage point, a proportion of each group. Then two numeric variables we have showed, yeah, in last class. We just use a scatter plot, which is point. Is bar point. Yeah. And you can add, of course, like last class we did, you can add a color, shape, and a group with shows in separate plot that, and so on and so forth. Okay, that's two variables. How about three or more variables? There are three variables. One is numerical. This is also numerical, and this is categorical, and this is categorical. So two numerical and two categorical. How do we do that? We also use scatter point, a scatter plot. But we can see that this one is red, so this is outline, and it's a triangle, so it's a dream. And this one is blue, so it's Jintu, and it's a circle, so it's Iskon. It's Bisco Island. So in this way, we can clearly show that, and of course, this shows the length, flipper length, and this shows body mass. So we can see that there is a positive relationship between flip length and body mass, which means that the flipper is longer and the body is heavier. And also we can facet it, use facets it. So we color and shape, we use the same we use the same categorical variable, and but we facet the element. What does it mean? Which means we show it in a different plot. So we use three plots to show the three. Yeah, and this is Biscone Island, Dream Island, and Pogson Island. And the red one is Adlai, blue one is the Gintu, and green one is the chin strap. And the X is still Philippines, and Y is body mass. Yeah, okay. That's the basic plot, scatter plot, bar plot, and what else? Scatter plot, bar plot. Yes, this part, and the box plot. Yes, box plot, and the density, and the histogram. Yes, but we can also, for example, has another kind of. For example, there are valuing. Yeah, we can change the, looks a little different, but actually it's the same as a box plot, just use a different shape. Okay, there are a lot of options. To be frank, no one can remember all of this, all of the functions or plots. What we can show you is that show you the basic arguments, basic functions, and the basic logics to coding. And if you wish to make it prettier or use a more use a plot you prefer more, so you can just go to the Google or some other platform to find the solutions. You can always find the solutions if you can understand the basic logic. So anyone has to ask for help from others or from internet. So no one can memorize all of this. So don't be scared if you thought this is too complicated. You can't remember all of this. You don't have to. You just know the idea, and for example, here is pipe, here is a plus sign, and what color is, and what the shape means, and labs means. Yeah, then you know the basic ideas, and you will, as times goes by, you will get it. So how do we save the plot when you created a plot? For example, if we use this one, we created a plot, and then we save it. Use the gg save. So this one, in this case, they will save the last plot you created. So here we run this, then this one is the last plot, then this one is the last plot you created. Then you use this one, save it. Okay. It will save to your current because the current, let me show you the current. So the current folder is online course. So in this online course, you will find the plot, this name, yeah. Okay. Yeah, it will show you this plot. It's simple and easy. But normally I will not save it because I read paper in R, so I can put the plot directly in the document I'm writing, in the paper I'm writing. And in the following class, in the future course, I will show you how to cross-reference this plot which you created. Okay. Okay, as usual, we have some homework which you can practice, and just practice makes perfect. And I will show you the outcome of the solutions to the homework, so you can check your answer. Okay, that's all for today's class. Thank you for watching, and if you like it, you can share the channel and the tutorial to your friends, and press the like button. And also, if you have any questions or suggestions, just leave a message below. Okay, see you next time.